So yeah, good evening guys. So for today's video, I will going to make my midterm examination for my subject data mining. So here's what I'm going to make. The notebook. Make a recorded video discuss and explain the process flow and hierarchical cluster and answer the analysis questions. In addition, make sure your face is visible and use an English language for the discussion. So I'm going to show you the load and explore the dataset, pre-processing standardized data, generate a dendrogram, apply agglomerative clustering, and visualize the clusters. And then I will answer the analysis questions. So yeah, let's start. So, first, I'm going to open my Jupyter's Notebook application. So yeah, let's wait for it to redirect us in our Chrome extension. And still loading, and zoom it in. And now I'll make a I'll delete this one. I will gonna make a new folder named hierarchical underscore hierarchical clustering data, hierarchical clustering data underscore. Then I will, since there's a hierarchical clustering data, so I put a underscore there to put some points in data. So I'll open this one. I'll upload the downloaded CSV named student info for clustering. Then I'm gonna upload that one, open the notebook, and select, and I will rename that one into what should I name it? Hierarchical clustering data. Hierarchical underscore clustering underscore data. Then turning it, I will start the code. So first, I will import pandas, numpys, and matplotlib pyplot. So first, I'm gonna import pandas as PD. Then import numpy as np. Then import matplotlib dot pyplot as plt. And then I'm gonna input from sklearn dot cluster import. Gonna import agglomerative clustering. Then enter, and I'm gonna also input from sklearn dot the composition. I'm gonna import PCA run, and I gotta import skipi dot cluster dot hierarchy as ECH. Then I'm gonna make the data frame equals pd dot read underscore csv, open and close parentheses, quotation marks. Then I'm gonna upload the name of our file, which is in the stop. Then student info for clustering. Student info for clustering. Student underscore info underscore for underscore clustering dot csv. And then after that one, we're gonna run this one, and after that we will define the variable for our data sets, which is x, or should we say I, x na lang, x equals df dot iloc to locate the location, and then we're gonna print or show the data frame. And as you can see, we see the student age, GPA, study hours per week, extracurricular activities, and attendance rate of the students. So we finish show the data frame. Next, we're gonna clean the data by printing our variable x. So it shows the data in the variable x, and then we're gonna input x equals x dot select underscore dtypes include equals numpy or np dot number. Then x is equal to pd dot get underscore dummies. Then x, after that we're gonna input x equals x dot as type float. This code ensures that the variable x will read only numerical numbers or floats. After that, we're gonna show the data frame, the clean data frame. As you can see, there's nothing to be clean. Actually, it is not necessary, but I'll input this one because to ensure data is secure and clean inside the variable x. So now we're gonna make the dendrogram. So since I already input the import skipi that clustering at hierarchy at the top, so I'm gonna input here the feed size equals 10 by 7. It is the size of our dendrogram. So I'm gonna make the dendrogram right now. Dendrogram equals SCH or the skip or the skipi cluster or hierarchy dot dendrogram SCH dot linkage. Here I'm making the linkage x, our variable of the datasets, and the method of our linkage, which is set to word, and then the metric equals, and the metric of our Euclidean distance. And outside this, to ensure that there is no black below our dendrogram, so we're gonna put no labels because it is the labels who makes that black patterns below the dendrogram. After that, we're gonna put some title or header for our dendrogram. Title equals to, or open close parenthesis, equals to, I'm gonna caps lock this one, dendrogram for student clustering, yeah. I'm gonna also put PLP X label, gonna label the x-axis of our dendrogram, which is index of students. And also, if we put some title or label in our x-axis, we will also put some title or label in our y-axis. Then we're gonna put Euclidean distance, because the y-axis could be our Euclidean distance. And then after that, we're gonna show our dendrogram. So let's wait for unexpected error in the no label. Oh, sorry, I forgot the letter S here, and then I'll try to run it again. Oh, there's an error again. Oh, it's a wrong spelling here. No label. And then yeah, so here's our dendrogram right now. So here is our dendrogram right now. So based on our process of standardize to generate a dendrogram, so we are finished in this 1, 2, 3 outline. So we were heading to our fourth outline, apply agglomerative clustering. So I will apply the agglomerative clustering. So let's go. So to apply, we're gonna HC equals agglomerative clustering, open close parenthesis, we're gonna call it n underscore clusters equals none, comma, and the distance of our Euclidean, or the threshold of each cluster. So we're gonna put I would say 250, or I would say 300 equals 300, and then I'm gonna input hc dot fit, open and close parentheses, to fit it in our dataset X. Then I'm gonna run this one. So agglomerative distance threshold 300 and clusters is none. So I'm gonna print number of clusters formed, and then comma hc dot n underscore clusters underscore. So the number of clusters formed is 2. In the based on the Euclidean distance, there are 2 clusters here, like, and we can show it in that blue line, like 1 and 2. So this is the clusters inside the Euclidean distance of 300. So if we say Euclidean distance in maybe 100, so we're gonna run this one. So the Euclidean distance, or the clusters inside the Euclidean distance of 100 is 9. So we're gonna count this one: 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 clusters inside the distance, the Euclidean distance, or the threshold of 100 here. So for me, what insights can you gather from each cluster? For example, the students in one cluster tend to have higher GPAs and study more hours. So maybe in the gathered clusters, the insights that gathered in each clusters is that, I'll go back to this, is that students that has higher GPAs is general percentage average maybe is maybe one class will tend to higher GPA. So they have students who gather from insights. For some students, one class will tend to have higher GPAs and study more hours. So students that has higher GPAs must and studying more study long hours per week, is that they should continue that one, and also they don't forget to make their attendance, because although they study more longer than others, but they have also higher GPAs than others, they must consider their attendance rate also, because even though they have longer hours studying every week, but their attendance rate maybe per week is lower than others, so they will get a higher GPA, which is not good for a student. So that's how. So parameter tuning, try experimenting with different numbers of clusters and observe how the clustering changes. So as I make the clusters higher, Euclidean distance, like I try it in 300, I see two clusters only. But when I put my distance or threshold or Euclidean distance lower, I get more clusters. So it means that the lower the Euclidean distance, the 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 higher the chance of the clusters you will get. So yeah, so additionally, it's meant to be by plotting other feature pairs to see if clusters are so in the additional features, we must show a scatter plane or scatter graph. So to show the scatter graph, maybe we will input PCA equals PCA n underscore components equals 2, and then x, we're gonna call our variable for our dataset x equal underscore PCA equals PCA dot fit underscore transform our x datas, and then gonna run das one, and then here we're gonna show our scatter graph. So plp dot figure, we're gonna input our figure size for our scatter graph, which is also a 10 by 7 dimension. And then we're gonna, so now we're gonna plot our scatter plane or scatter graph. Scatter plane equals x underscore PCA brackets is 0, comma x underscore PCA 1, start, because we are starting to count from 0 until the 1, and then comma, then c equals hc dot labels underscore comma c map, or we're gonna do the mapping, and then equals rainbow comma, and then we're gonna label equals clusters. Cluster only. Then we're gonna plot again that title we're gonna name it agglomerative clusters PCA dash reduce enter, and then we're gonna plot again that x label. We're gonna label our x as principal component 1, or it means only components 1. So here we're gonna also plot, if we label our x, we're gonna also label our y. So we're gonna name it or label it with, since we put component 1 in our x label, so we're gonna put also components 2 in our y label, and then enter, and then we're gonna plot again that color bar to show the colors, the mapping, the color mapping we put here is rainbow. So we're gonna put the color bar and then label equals cluster. Enter, and then after that we're gonna show the scatter bar, or the rainbow bar, or the scatter bar that we make. So let's try it. And then, oh, there's an error, so fig size. So I have an error in the fig size. So I have an error in fig size. So, oh, I forgot to put in an equal sign. So I'm sorry for that. So yeah, so here is our agglomerative clusters PCA reduce. So to explain this one, so from 0 to positive 15, 0 to positive 15 is under the cluster 4 up to 8, and 0 up to negative 15 is under the clusters 4 to 0. So it means that from, as you can see that, the blue or the violet and blue until the yellow green color is in the positive side, or in the positive quadrant of a plane. It means that the clusters from 0 to 4 has a lower GPA and has a higher lower GPAs, which is good, and students from 0 lower GPA and has also a very impressive attendance rate. So yeah, I think we answer the additional features, and we also apply the agglomerative clustering, and we visualize the clusters by making dendrogram and setting a threshold here. So I think that's all for our midterm examination. So thank you for that. Thank you for listening, guys. So yeah, have a nice night, and good night, guys. Yeah.